So the first half of this is going to be review from last year. The second half of it is going to be brand new. I really like this unit because I feel like it's the first time I teach you something that is totally brand new, like you have never seen it before, because we do a lot of review of Algebra 2 and just kind of maybe like add in some slight new things, but it's like an actual new topic. But we'll do the first half and we'll see how much you remember from last year, and then we'll do a break and then we'll do the second half. So we're getting into polynomials. We just finished quadratics. Quadratics are a type of polynomial. But a polynomial is a graph that's gonna like turn and bend and do all kinds of stuff. So characteristics, it has a continuous smooth curve. And we talked about continuity. Do you remember discontinuity at x equals whatever? And we talked about removable and non-removable, continuous smooth curve. But do you guys remember discontinuities? I was talking about that. Yeah, like what would be a discontinuity? Like what is something that would cause a graph to be discontinuous? What would it look like? A jump, or what else? A break, which would be a jump, or what else? An asymptote, good. And then the other one? A hole. These don't have any of that. None of that. They are all continuous. You can trace them without lifting off of the paper, okay? An even degree means the ends go the same way. So what we need to remember about the fidgets is that they're designed to help you be more focused, not less, okay? So if the ends go the same way, it's even. For an odd degree, the ends go opposite ways. Which is convenient, odd, opposite. The ends go opposite ways, it has an odd degree. Now, oftentimes you get asked for the least possible degree. So it's the number of turns plus 1. So if you count how many times the graph bends or turns and add 1 to that, that's the least possible degree. Now, please listen, because I'll get people that'll answer, is the degree even or odd? And they'll say even. And then for least possible degree, they'll put 5. Now, I'm okay with mistakes being made and stuff, especially when you're learning. But if you say it's even, can you at least put an even number for me? Like, can we use our common sense on that? Like, if you say it's odd, at least put an odd number, okay? If your leading coefficient is positive, then the right side goes up. And if your leading coefficient is negative, then the right side goes down. So what's a little uncomfortable about these is you only know what the right side is doing. So we graph them right to left instead of left to right, which is backwards from everything else we do in life. But if you're left-handed, this is your thing. You're gonna go from right to left. So let's answer a few questions about this graph that I showed you. And these should be arrows on the ends. Like if you want to put arrows, it's going to keep going. Sorry, there just weren't arrows on the ends of that. So is the degree even or odd based on what I told you about even or odd here? What do you think? Good. Why is it even? Both go in the same way. Easy as that. All right. What is the least possible degree? Now, even if you mess it up, can you at least put an even number for me? Okay. You're going to count the turns and then add 1. Now, I don't have a better explanation than, hey, look. So can we count them together? Look, 1, 2, 3, 4, 5, plus 1, 6. And 6 is an even number, so good job. And then is the leading coefficient positive or negative? You have to look at the right side. It's going down, so negative. Cool, we survived that. Now, this is about pattern finding. If your multiplicity is 1, and what we mean by multiplicity is the power, like the exponent that's written. So if it's 1, it's usually not written. What that means is the graph crosses the x-axis. It would look like a line. Linear is a power of 1. When you have y equals mx plus b, it's x to the 1. So linear is a power of 1. Multiplicity of 2 means your graph bounces at the x-axis. A power of 2 is a quadratic. When you have an x squared, that's the unit we just finished, you get a parabola. Is this ringing any bells, sort of, from last year? I love this topic. What is it for 3? It wiggles at the x-axis. And so it's going to look like a cubic graph. What I always get is somebody's like, I can't draw that. I'm not here to grade your art skills. So what I want you to do is make an attempt to get it to bend. All right, and I'll know what you meant, but if you just want to write the word wiggle next to it, that's fine. Okay. And I just want to add in there, because we don't go beyond 3 when we're graphing these. But if you have an even multiplicity, and I'm just going to abbreviate multiplicity. If your multiplicity is even, it's going to bounce. Bless you. And if you have an odd multiplicity, it's going to go through the x-axis. All this that we're talking about is at the x-axis. So for example, because we're not going to graph beyond 3, but say you had a power to the 12th. Say the multiplicity was 12. Is 12 even or odd? Even. It would bounce back. Say it was a power of 57. Is 57 even or odd? Odd. It would go through. Do you get what I'm saying? So if I asked you about one higher than 3, that's how you tell. All right, so we're going to graph these. I love this. It's like doodling in math class. It's fantastic. Now you're going to put your points on the x-axis. I can put a point at 4, so right here, and at 1. How did I get those? And I set them equal to 0 because they're zeros. It's on the x-axis. It's the points 4, 0, and 1, 0. Now you have to go right to left. Do you see a negative out front here? No. You won't see a plus sign, but if there's not a negative, then it's positive. The right side's going to go up, and I'll usually just draw a little arrow. And then you connect the dots, and you have to cross, bounce, or wiggle accordingly. Now, here's what you got to be careful about. These could be written in any order, so you have to make sure you match up to the right one. I'm going to start here. When I connect to the 4, that comes from the factor that has the 4 in it, guys. That means you're going to bounce because the multiplicity is 2. So when you get there, make it look like a parabola. And then when you get to the 1, that comes from the factor with the 1 in it, guys. It just goes through because there's nothing written, so that's understood to be a power of 1. So it's going to look like that. I was just going to bring that up. Do we know how far up this goes without a calculator? No. The only points you're getting specifically are these 2. The rest of it is like good enough. This does bother some of my very type A people that like for things to be perfect. So for you, I would say take a deep breath and just understand it's not going to be perfect. Some things in life aren't, okay? Doodles, that's what we're doing. We're doodling. All right, let's try it again. What are the x-intercepts that I can put? Good. -3, +2. What you're doing is setting those equal to 0, but I mean, most people just remember it's the opposite number. Do you see a negative out front? So the right side goes down. Just draw a little down arrow and just make sure you match them up correctly. I'm going to connect from here to the 2. So I'm going to look at the factor that has a 2. What am I going to do there? Yep, just cross straight on through. It's a power of 1. So we're just going to go straight on through like a line. And then at the -3, what am I going to do? Wiggle. Okay, so watch. I'm going to turn around and it's going to look like a cubic graph when you go through there. But again, I always get some people that are like, I can't draw that. If that's the case, just write the word wiggle next to it and you're fine. It's like when you're 3 and you draw a picture of a dog, but it looks like a potato. So you write dog next to it so that everyone knows what it was supposed to be. It's just like that, okay? You want to try the next one on your own? Yeah. Okay, go for it. All right, so where'd you put the x-intercepts? Yeah, 3 and -3. Now that's a little bit tricky because one is 3 and one is -3. So let's see if you got them right. The right side is going to go down. Now, when I get to the +3, look, when I get to the +3, which one of these factors are we looking at? The first one or the second one? Yeah, the first one, which means we're going to bounce. The 2 means you're going to bounce like a quadratic. So like that. And then the -3 came from this one. What are we going to do at that one? Wiggle. How far down does this go? Not real sure. Okay. Did that go all right? Did that go okay? Okay. Now, people usually like this better. We're going to do it backwards because you don't have to draw a picture. The picture is already there for you. You're going to put f of x equals. I still go right to left with this just for the sake of being consistent, but it technically doesn't matter what order you write any of these in. But I'm just going to go right to left to be consistent. Do I need a negative out front or not? Yes. Okay. If it's going up, just don't put anything. So here's my first 0. It's at 4. So my factor is going to be x minus 4. Good. And then what's it doing there? Bouncing. So squared. All right. And then I have another one at 1. So x minus 1. And that one bounces. So also squared. And then my last one is at negative 2. X plus 2. And it just goes straight through. So you can either put the little 1 there or put nothing. You don't have to put anything if it's a 1. And again, these could be in whatever order. I'm just going to go right to left for consistency. All right, let's try number 5. Do I need a negative out front? No, so just don't put anything. All right, my first 0 is at 3. So that'll be x minus 3. And then what's my multiplicity? 3, it's wiggling. So cube, lots of 3's there. All right, and then the other one's at negative 4, so it'll be x plus 4 and also cube. Good. All right, and then last one, do I need a negative on this one? Yes, going down on the right side, so negative. My first 0 is at 4, x minus 4. It's going straight through, so you can put a 1 or just nothing. Now this one's a little tricky because where's the next one? 0. So you can write x minus 0, or you can just put x because x minus 0 is just x. And then what's the multiplicity on that one? Squared. Good. 2. All right. And then the last one is at negative 2. So we're going to put x plus 2. And what's the multiplicity on that one? 1. So you can write it or not. All right, that was the review of last year. Now we're going to get into the new stuff. And here's what I would like to have happen. You can end up getting really good at these. And what happens every year is people become little correct answer machines and just start churning out correct answers. But you have to watch to get the process. So what I want you to do is set your pencil down. I will pause after this and let you copy the whole thing. But if you look away, you're going to miss it because these start to go really quick. Okay. So we're going to do what's called polynomial division. And there's 2 methods. The first one is synthetic division. We'll do this and then we'll do our break and then we'll do the long division. So what you're going to do is look at what you're dividing by. And I'm going to give you vocabulary for all this after we finish the problem. And you're going to go, what makes that 0? So, hey guys, what makes this 0? A positive 2. Don't pick up your pencil. I'm going to pause and let you write it down. You can't look away. You're going to miss this. Whatever number that is, you put it in a little box off to the side. You're like, get over there. Okay. Then basically you're just going to thief all of the coefficients from the problem. But here's the thing. They have to go in order. So do you see how this is x to the 4th? X to the 3rd, x to the 2nd, x to the 1st, and then that's x to the nothing. Do you see how it's all in order? Okay, I'm just going to steal all the coefficients. So do you see how it's 2, negative 6, what's this one? 1, good, 5, negative 3. I'm going to draw a line. And here's the only thing that people generally mess up about this. Because again, this usually goes really well once you start to get the hang of it. Is they'll start trying to do the problem and there's not even a number there. And I'm like, what are you doing? Like, there's nothing there. You have to bring down the first number. And then it is multiply, add, multiply, add, multiply, add, multiply, add until you get to the end. Can you all multiply? Yes. And can you add? Yes. Because you don't get a calculator, I keep the numbers small and manageable. So if you get something that turns into the thousands, you have done goofed. I always get this happens on the test where it'll start to spiral out of control and people get numbers into the 5,000s. And I'm like, I told you I wasn't going to do that to you. You lost a negative sign somewhere. Okay. Like I'm not going to do that to you. Ready? 2 times 2, 4, I'm going to add the column. What do I get? Good. Now we're going to do it again. 2 times -2, -4. I'm going to add the column. 2 times -3. Add the column. Good. 2 times -1. Add the column. Now, I didn't write the actual answer yet because we have to put the x's back in, but did you follow me? Go ahead and write it down. I'm going to pause. All right, so here's how you actually write the answer. We have to put the x's back. Do you see how this started to the 4th? But we divided out an x, so you're going to start 1 less. I'm going to say that again. Do you see how this was a 4? We divided out an x, so we're going to start 1 less. So it will be 2x to the 3rd, and then it goes in descending order. It'll be -2x squared, -3x, -1. And do you see how there's a number left over? I'm going to go over the vocabulary in just a second. I'll get a different colored pen. That's called the remainder. And here's my suggestion. I always put plus no matter what sign it is, just so that the negatives don't get confusing. I just always put plus. And it will be that number over whatever you were dividing by in the first place. So in this case, x -2. So you don't have to do any more work with the remainder. You just tack it on at the end. And basically what you're saying is we were unable to divide that part out. Now I'm going to give you some vocabulary. I'll label these in pink. Let's see if you remember any of these from like 4th grade or whenever it is you do like this kind of division. This part is called the dividend. And to be clear, I'm not going to test you on these words, but I'm going to say them. And so you have to know what I'm talking about. Vocabulary is so that we can communicate, right? The thing you're dividing by is called the divisor. Whatever you get as your answer is called the quotient. Remember that word? And then this thing that's left over is the remainder. The words I'm going to use the most often are divisor, because what you're dividing by is the important part, and then remainder. Those are the two we're going to use a lot. Again, I'm not going to put on a test what's a dividend, okay? It's just so we can communicate with each other. If I'm like, hey, the dividend is blah, 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 you know which piece of it I'm talking about, okay? Now, I went through that one real slowly, but this is going to speed up here because you just multiply, add, multiply, add. So look at number 8. Look at the divisor. What number would make that 0? Good. -1 goes in a little box off to the side. Like, get over there, you. Now we're going to check if our countdown's in order. Look, do you see how we have an x to the 4th? And then it goes straight to a squared. Do you see that? Here's what you do when you're missing one. How many x to the 3rds do we have? None. So you would put a 0. Okay, so we have 3. And then we have no x to the 3rds. There's 0 of them. And then -2x squared, 4x, and then the 8 is left over. So make sure your countdown is in order. Draw a line. And you can't start until there's a number there. You have to bring down the first number. People always start like without bringing that down. And I'm like, how are you even doing that? Like, what are you doing? Because there's not a number there. Okay, we're going to multiply, add, multiply, add. You ready? -1 times 3. Good. Add the column. Now do it again. It's cyclic. You just keep doing the same thing over and over again. -1 times -3. 3. Add the column.
1.
Beautiful. -1 times 1. -1. Add the column. Perfect. -1 times 3. -3. Add the column. Do you see how all the numbers stayed small and manageable? If that doesn't happen, you have messed up, because I'm not going to do that to you. Now, when you go to write your answer, what power are you going to start with?
3.
Why 3? You divide it. Good. 1 less than what you had. So 3x to the 3rd minus 3x squared plus 1x plus 3. 5 is the remainder, so I'm going to put plus 5 over what? X plus 1. That's the answer. I'm going to skip down to number 11. Okay. What, or did that go okay? Nope. Okay, you guys are paying attention. I'm seeing heads nodding, so that's awesome. Skip down to number 11. Look at your divisor. What number would go in the little box? Perfect. Yeah, there's a little trick to those other ones. I'm going to come back to that. So -3. Check your countdown. Is it in order, or are we missing something, or what's going on? We're missing the squares. There are none of them. So let's list out our numbers. What's in front of the x to the 5th? All right, so we have 1, 2, then what? -2, then 0, no x squared, then -4, then -5. Draw a line. And you can't start until you do what? Bring down that number, the first number. Multiply, add, okay? -3 times 1 is -3. Add, good. -3 times -1, 3, add 1. -3 times 1 is -3, add -3. -3 times -3 is 9, add the column 5. -3 times 5 is -15, add -20. Do you get how you can just churn them out? You can just start to churn these out, okay? Now I'm going to start with x to the 4th. So it's 1x to the 4th minus 1x to the 3rd. And you don't need these ones there. I'm just putting them to show you where it's all going. All right. Plus 1x squared minus 3x plus 5. Good. Plus, and then it's -20 over x plus 3. I have found over the years that if you just always make this a plus, it doesn't end up confusing people. Just always put a plus and then whatever number over your divisor.